Okay, question 5.1. Right, with this question, the first thing I'm going to do is I'm going to break down each one of these four forces into their horizontal and vertical components. So for this force here, our horizontal component is acting to the right, vertical component is acting straight up. For this force here, we have no horizontal component, no vertical component, only horizontal component. And this one here has only got a vertical component, no horizontal component. This force in here has got a horizontal component acting that way and a vertical component acting straight down. The easiest way to solve this one, if you're not going to do it purely graphically, is you need to draw up a table of forces. So I will have one column with my X forces acting to the right as being positive and my Y forces acting up being positive. Okay, so I'll label this force as force 1, I'll label this one as force 2, force 3 and force number 4. So force 1, 2, 3, 4. I will have a sum of my X and Y forces at the bottom, and that will be my table. All right, let's have a look at force number 1. Its X component or horizontal component is acting to the right, which means, according to my rule, it's got to be a positive force. So it'll be plus 3.68 newtons cos 45. The vertical component, in my case acting down, so it must be minus 3.68 sine 45. So what I've done there is the horizontal component is that one, which is 3.68 cos 45, and the vertical component, because it's acting downwards, is minus 3.68 sine 45. Force 2, our horizontal component is positive, so it will be 8.61 cos 45, and that is the formula for that force acting horizontally. Our vertical component is there, it's acting up, so it must be positive, so it is positive 8.61 sine 45 degrees. Okay, force 3 is this one acting straight down. Because it's acting straight down, there is no vertical component. As it's acting down, its vertical component must be negative, so it's minus 4.85 newtons. Force 4 is acting to my left, so it has a negative X action, which is minus 6.91 newtons. It has no vertical component. If I add my X column, the sum of the forces in the X direction end up being minus 0.0028 newtons, which is insignificant and in actual fact is closer to zero. If I add all these forces, it ends up being 0.004, which is upwards. That also is insignificant. So I would consider that the sum of the forces is 0. So the system is in equilibrium.